Okay, so let's do this question. So we're given the following circuit. It says, what is the current drawn from the battery? What is the terminal voltage of the battery? And what is the voltage drop and current across the 4 ohm resistor? This is going to be very similar to what we did in day 2. We're given those more complicated circuits, but we're just adding in that internal resistance. This one I drew the little R to the right of the positive. It doesn't really matter. As long as you have both that EMF and that internal resistance in there, we're good to go. So let's solve for this one. Okay, so first thing, whenever we get a question like this, we're going to find our equivalent resistance. So if we want, we can include this 1.5 into our equivalent resistance, or we can not to. It doesn't really matter. You can kind of decide. But I am going to include it, so let's solve for REQ. So hopefully by now we're a bit more proficient in solving for our equivalent resistance. So when you look at this one, we can see that there's 2 ohms and 8 ohms. Those are in series, so 2 plus 8 is 10. And that's in parallel with the 4. And then this whole top piece, those 3 resistors at the top, are in series with the 6 and 1.5. So we actually create an equation. So we're the resistance, that 1.5 ohms is in series with the 6 ohms, which is in series with this parallel piece. So 1 over 4.0 ohms plus 1 over 2.0 ohms plus 8.0 ohms. Again, you don't have to do it all in one step. If you can, just do it. We find out our REQ is equal to 10.36 ohms. Okay, so that is the overall resistance. So again, if we were to redraw this circuit, we have a single 12 volts being supplied, and there's a 10.36 ohm resistor. So let's find out what our current drawn is. So I is equal to V divided by R, which is 12 volts over 10.36 ohms, and we get 1.16 amps. So that's how much current is being drawn by the battery. Now we can find our terminal voltage. So VAB is equal to, again, here's our AB, right? Just cross those two things. So what is the actual voltage that we're supplying to the circuit? So we have 12 volts and subtracting our current 1.16 amps multiplied by our resistance 1.5 ohms. So we get 10.26 volts. So even though it's a 12 volt battery, we're only effectively supplying 10.26 volts to the rest of the circuit. As if your load that you're attaching a battery to is a lot bigger, than that difference between the terminal voltage and the EMF will be smaller. So it's not, but whenever the voltage that we're attached to is quite close to our internal resistance, we will see quite a significant drop. Okay. So different ways we can solve for you can just work your way through it and solve it. You can kind of go a bit faster as well. I can use a little bit of nodal analysis. There's just some ways we can do it. I'll show you 2 ways. Nodal analysis. Again, you can always just do it like you did in day 2. Just work step by step, like find the voltage here, find how much voltage drop from 6.0. But using nodal analysis, I can say, okay, I have some current I, and that's going to split into I1 and I2. So I say, okay, I is equal to I1 plus I2. Now we already just solved for I1, so that's we just solved for I, so 1.16 amps. And at this point, we can just call this V1 at this node. At and we know over here is 0 volts, so we're going to consume all our voltage. When there's only one battery, it's pretty straightforward using nodal analysis and loop law. So we know V1 over 4 is I1, and I2 is just going to be V1 over 10. Very simple expression we created. V1, just add those things up, a quarter plus a tenth. So far we have V1 is equal to 3.31 volts. Okay. When therefore across that 4 ohm one, we get 3 positives. That is our answer. If you want to find current there too, I1 is equal to V1 over R1, which is 3.31 volts over 4 ohms. We get 0.83 amps. Another way we can do is, because just like our ratio of currents, like all like I1, sorry, current goes in and split from I1, I2 is proportional to the resistors. This is what we call ratio of currents. First of all, we need to know what the REQ for the parallel paths is. If we want to do it this way, parallel paths. If you have two parallel paths, you find the REQ. So that, in other words, the 10 and the 4, and that comes out to be 2.857 ohms. So I can say I1 is just equal to REQ over R1, I1. So that's 2.857 ohms over 4 ohms times 1.16 amps. And we get that same current, 0.83 amps. Right. Again, what we did there, we went a 1 over 10 plus 1 over 4 inverse. Take the number divided by 4 times 1.16. And we are done.